Today is National Battery Day. Guys, these days have been real awesome lately. National Battery Day, it is a day to celebrate the fact that we have lots of things that run on batteries. That's really what it is. You got a funny joke. How much do dead batteries cost? Nothing, they're free of charge. Because batteries don't have charge yet. They're free of charge. Yeah. Let that one sink in. Just have a great like dad joke dad joke Thursday morning. Or if you like this one, I'm feeling positive today. Batteries are positive. I thought, yeah, National Battery Day. Why not? Let's have some jokes. So estimation of the day. How many batteries do you think you have in your room right now? I have one in my cell phone. I have one on my computer. I have one in each of the like 3 remote controls that I have. That's actually not that many. That's only like 5. What am I thinking of that runs on, what am I not thinking of that runs on batteries? Diana thinks 45. Roxana says a lot. Gabby says 20. Oh yeah, gazillion because of your sister's toys. And the funny thing is we learned about batteries in physics. Yeah, physics and math are always so aligned. For sure. Did you learn about free batteries because they're free of charge? Maybe not. Noemi has 7 batteries. Oh, Diana has a battery pack on her shelf. Yeah. I guess I could count those. I have 3 batteries just like floating around. That's true. That's true. All right. Well, happy Battery Day. I don't know how you can solve it, but or how you can celebrate it, but sounds like a fun day. 45. Gary, that's just an estimation, or did you actually count 45?
Me plus my, because I have battery packs in my like drawer, plus everything that I have, like my electronics.
Yeah, that makes sense. I'm also wondering about like what types of things have batteries and I'm not thinking about because they're technically plugged in, but they might have like reserve batteries. Oh, like your watch might have a battery. That calculator has a battery. Yeah, batteries control our whole lives, so pretty cool. Anyway, free batteries. That's their joke of the day. All right, we're gonna jump in. Here is our agenda for today. We're gonna jump into announcements and then we're gonna jump into Desmos. And our Desmos will have our notes and our assignment in it. So to answer Gabby's question from earlier, you aren't gonna need paper today. So I know some of us are like, yay. If you love paper and you wanna keep writing on paper, feel free to keep writing on paper. That's okay too. You don't have to write on the computer, but the notes will be starring Ms. Yama this morning. So Ms. Yama is going to help us with the notes, and then we will both help you with the assignment today. So I'm going to jump in. For our announcements, we had a really awesome resubmission day on Tuesday. We had, as of last night, we had 26 new submissions. I think we're actually at 29 because I got a few more last night. So thank you to those people who submitted last night. We had a lot of you all take math rest days. I'm happy about that. I'm glad that you took some rest. More people are passing, which is awesome, and more people have A's, which is really awesome. So those are always my 2 goals. I want everybody to be passing, and I want as many people as possible to have an A. So it's awesome. I see you. Keep up the good work. Like we're full of the memes today. All right. So we're gonna jump into Desmos this morning. I'm going to go ahead and send you this link here. You can also find it in Canvas, but I think the easiest way is to just go with this link here. And then I am going to toss it over to Ms. Yama. So I will stop sharing my screen. And Ms. Yama, it is all you.
All right, and I'll start sharing my screen. Cool. Can we see the screen? Give me a thumbs up. We practiced this. Thank you. Thank you. All right. Cool. Okay. Here we go. All right. So today we're going to be talking about Pythagorean theorem. Can I have like a hand raise if we've done this before? Because I know that we've kind of covered this topic before. Thank you. Cool. Okay. All right. Thank you. So with Pythagorean theorem, to use it, you need to have your right side, your right angle, which is your 90 degree, and the two sides that touch the 90 degree. There are that we call those sides legs, and then the side that's opposite of the 90 degree, it's what we call the hypotenuse, and that's always the longest side of the triangle. And we write Pythagorean theorem as a squared plus b squared equals c squared, where a and b are legs and c is a hypotenuse. You can also call it leg square plus leg square equals hypotenuse square, or opposite square plus adjacent square equals hypotenuse square. Adjacent just means that it's right next to it. Okay, so that's like a review part. All right, so right here, can someone tell me where my A and B would be? Let me see if I can get the chat going. Thank you, yes. Feel free to come off mute, or you can type it to me directly.
A and B would be where they meet. So it's where that letter L shape would be at.
Could you repeat that again? Sorry.
It's where they would meet on the corners of the inner square, that little letter L shape that you can sort of see.
Yeah.
That would be your A and B.
Yeah, that's perfect. So what you were saying essentially is right here, right? The right angle. So A and B will be the sides touching that right angle. And then the side across from that right angle would be our hypotenuse. That's perfect. Thank you. Ms. Mack, should I continue or should I wait for people to come in?
Let's go ahead and wait a moment. It looks like a few people are still logging in. Y'all, I'm going to send this link one more time. Oh, not that one. So sorry. This one. Go ahead and log into this Desmos. See, many of us have gotten there. 26 of us have gotten there. But I know, Sebastian, I'm still looking for you to get there. I know, Desiree, you just got here. If you just got here, feel free to jump in. You're just gonna log in with your Google account, your Hybrid High account. When we're actually going through the notes, what Ms. Yama has on the screen is the notes. So she's on slide 3. So you would want to also be on slide 3, and you're going to do exactly what she's doing on her screen. You're going to do on your screen. So since she labeled A and B, you're going to label A and B on your screen as well. You shouldn't have to download anything, Sebastian, I don't think. It should just open in like either Safari or Google Chrome, like as a tab. You should be able to jump in there. It might take just a moment to load, but we can let it load really fast. Let me just make sure we got everybody here. So go ahead and make sure that you are logged in. Thank you to everyone who has made it in here. Appreciate you. It might still be loading. So Adrian, you're going to want to go to that link there. Make sure that you're logging in. Thanks for pausing, Ms. Yama. Ashley, make sure that you've logged in real fast. Izzy, make sure that you've logged in real fast. And then I think that's everyone so far. So why don't we just go ahead, and everyone should be on page 3. And you are actually like drawing your letters A, B, and C on there. So go ahead and draw A, B, and C. Everybody should be on page 3.
All right, thank you, Miss Mac. So a quick recap, what we did, we labeled the sides of our triangle. So our legs would be the two sides that's touching our right angle triangle, our right angle, which is our 90 degree. And our hypotenuse is the side that's across from our 90 degree. And we label it as C. Okay, so let's try to label C and the legs A and B. So can someone tell me what my first step would be before I can start labeling? You can type it in the chat, or you can just come off mute and let me know.
You have to look at the little square and then look to the, I don't remember what it's called, I'm sorry.
No,
And
you're fine.
it's opposite to it, and then there'll be the
Mhm.
long line, that would be C. And then the
Yeah.
other legs would be A and B.
Thank you, Gabriella. So the little square that you were talking about, this right here, it's called the right angle. It's our 90 degree. So you're perfectly right. So the two sides touching the 90 degree, this side would be A and B. They can be called interchangeably. This can be A, this could be B too. And the side across of it right here is what we have as C. All right. Okay, let's try with an actual example. So our steps are A, to mark legs and hypotenuse. B, substitute into our formula, A squared plus B squared equals C squared. And C, solve for the missing side by our calculation. Okay, so our first step is to find our 90 degree, our square, our right angle. So with this, we know that this side and this side, these two sides are our legs. So we could call this side A and we could call this side B. And that would leave this other side as C. Okay, so we could write our formula A square plus B square equals C square. So I'm using my trackpad, so my letters aren't that straight. And then we can sub in our numbers. So A right here, we have 4. So 4 square plus B, which is our 8 square equals C square. Okay. So if we do the calculation, can somebody help me out? 4 square would be?
16.
Thank you. 16 plus 8 square?
64.
Thank you. Awesome. 64 equals C square. You know how in our lessons in radical, when we want to get rid of the square, we want to square root both sides. So what we'll have is, let me see if I can add a color right here. Should work like this. Oh, not awesome. So we want to square root both sides, so get rid of the square. So we would have C equals, oh man, equals square root of 80. Can someone put it in decimal real quick and give me a 3-digit number of square root of 80? Thank you. Wow, that's really quick. Thank you, Marcy. So we have 8.94. And that's how we solve for this question. So far, so good? Yeah? Can I have a little emoji? if that's good. Any question before we move on to the second one? Cool. All right, I'm gonna move on to the second question. What we have here, again, our first step would be finding where our right angle is, which is right here. And after we have our right angle, we can tell that this side and this side, these two sides, are legs. So we're going to call 3.9 our A, our B is unknown, and the side that's opposite of our right angle, this side, would be our hypotenuse. So again, we write down our equation A squared plus B squared equals C squared. This time, can I have you guys help me fill out and substitute into the equation?
So it would be 3.9 squared plus b squared equals 11 squared.
Yeah, that's perfect. 3.9 squared plus b squared thank you, Ms. Beck, equals c squared. Okay. 3.9 squared, you can put it into your calculator. You can use Desmos or you can use your calculator like I'm using right now. So 3.9 squared will give us 15.21. Thank you. 15.21 plus b squared equals, this should say 11. 11 squared is 121. And what should I do next? How can I move around my numbers to solve for b squared? Yeah, that's right. We want to subtract both sides, 15.21 on both sides, because we want to single out our b squared. So this is what we're gonna have. Oh, thank you for bearing with my numbers. They look really squiggly. Okay, so this should be 0. 121 minus 15.21 should give you 105.79. So we're left with b squared equals 105.79. How do we single out the b? Class.
Root?
What?
Do you square root?
Yeah, that's right. You want to square root both sides. So you want to square root that, and you want to square root this. So you can just plug it into Desmos or a calculator. So you should get b equals 10.285. I usually round it to 2 decimal number. So you should get 10.29. And we get this number. We get this number by square rooting 105.79. All right, let's pause for a little bit. Are we getting the overall idea? Take some time to jot down the note. Thank you. Thank you for the messages. If you have everything down in your note and we're done with the slide, please give me like a thumbs up so I know. Thank you, Jasmine. Thank you, Gary. Thank you, Roxana. Thank you, Sebastian. So we're ready. We'll take about another minute or so before we move on to our next slide. Okay, so I can write down my answer here actually. All right, cool.
Hey team, I wanted to jump here and just answer a question really quickly. If you're struggling with the Desmos and the Desmos is really hard to write on for you, shout out to Miss Yama for making it work. If you would like to use paper, if that just like works better for you, then you can use paper. I'm just gonna have you email that paper to me when you are done today, okay? So Desmos is better because I can see your work and I can correct it as we're going. But if you like really can't make it work, then paper is okay. So just wanted to jump in with a little note. Thanks, Ms. Yama.
Thank you, Ms. Mac. And thank you guys for bearing with my handwriting. I know it's not the prettiest we have so far. Okay, so I think we're confident in moving on to our next slide. So here we go. Our next slide. Okay, so this is a little different. We have a few more steps before we can actually solve it. We have to plot our lines. So we have the 2 points we have here are 2, -3, -5, and 0. And recall that the first number, can I write here? The first number right here. Okay, it's not letting me write. So this number 2 is our x value and -3 is our y. So let's try to plot it out. I usually try to find my x and I'll make a note here. So this is x at 2 and we want to go down to -3. So we want to go down 3, 1, 2, 3. So our actual point would be right here. And this, let's note it, would be 2, -3. So that's our first point. Our second point is -5 and 0. So -5, you want to go to the left side of the x-axis. So you want 1, 2, 3, 4, 5. You want to be right here. And since our y is 0, we can just fill it in right here. So we can draw a line right here. It's kind of squiggly. So this is our line. And I'm going to tell you right now that this is our C. Can someone tell me why I can tell that this line right here is our C? Like the distance between the 2 points, why is it C? You can come off mute. You can message me privately. Take some time to think about why I can tell for sure.
Is it across the 90-degree angle?
Yeah, exactly. Yes, because our 90-degree right here, our angle is right here, right? And like we said, our hypotenuse will be across of it. So that's perfect. Thank you. So with that, we know that the two sides touching our 90-degree is our legs, right? So we can just call this side A and B. Do you have any idea how we can figure out our A and B? Counting the squares, yes. Great. Yeah. So with this example, we can actually just count out the square because it's kind of a small example. But usually what you could do is you could look at so for B, we can look at our Y. And for our A, we could look into both of the X values for the 2 points. And what I mean by looking at our b, the y in our b is right here. You see that we went down 3. So our distance for our b would be 3. Does that make sense? Okay, fair enough. So if you look at our b, right, this side is our b. Yeah, of course. And you want to count the square. That's a method that was given in a private chat. So if you count down, it's 1, 2, and 3. So that's how you could count using the counting square method. Or the other method that you could use is you could look at your y. So y here is a -3. It means that it went down 3. Does that make sense? Feel free to message me. Cool, awesome.
So I have a question. So since the
Mhm.
y is -3, we just change it to a positive or okay,
So that's a great question. So because we're talking about distance, we can think of it in, you can't really think of distance in negative space. So you want to put the absolute value when it comes to distance. That's why I changed my negative to a positive. But that's a great observation.
okay. Thank you.
Awesome. Okay. So I think we're going to move on to how we get A. So A is slightly trickier because you see how with A, we're taking into account our point, the 2 and the -5. So what I mean is this. Let me see if I can change my color. So from here, we have -5 to 0. And then here we have 2, right? Because we have 2 points. And on A, we have to look at the x values. So we have -5 from here, right? 0 to -5. And then right here have 0 to 2. And like Gabriela said, we want to put an absolute value because it's distance. So no matter if it's negative or positive, we want it to be a positive value. So if we put an absolute value on the -5, that will give us 5. And we want to add the 2 from here. And from there, we can arrive at 7. Does that make sense? If it does, please give me a thumbs up. If not, I can find another way to explain it again. I want to make sure that, so for A, we're looking for both. Yes. Yes. So for the A, we're looking for the x's, and for the B, we're looking at the y. And for A, we're looking at x because it went this way, right? And for B, we looked into the y because it's vertical. And that's how you decide which value, which x or y you're looking at. Yes, and then you want to add them because we have 2 x values. Those are perfect questions. Cool, cool, cool. Okay. All right, seems like we are good to move on. So from here, we can tell that our A is 5 plus 2, which is 7, and our B is 3. So we could actually write out our formula. So if we use a squared plus b squared equals c squared, then we would have 7 for our A, 3 for our B. So we want to do 7 squared plus 3 squared equals c squared. Yeah. Okay, so 7 squared. Very quickly, can someone shout it out to me?
49.
Thank you. I'm just gonna plug it right here. So 7 squared is 49. 3 squared is
9.
Thank you. Yeah, 9. And then we'll get our c square. Okay, so 49 plus 9 is 58. And like we did in the previous problems, we want to square root both sides to get rid of the square. So we will arrive at c equals square root of 58. Can someone quickly plug that into a calculator? Oh, thank you. Well, you guys are ahead of me. Yes. So you'll get 7.615 rounded to 3 significant figures, and you should get 7.62. Yeah, I know this one is a little bit more complicated. Ms. Mack, could you launch like a poll for them? Thank you. Let's see how we are doing.
So y'all may need to pop back over to the Zoom. If it didn't pop up for you, you might have to click into Zoom. One thing I would also argue here, y'all, is I think at one point somebody said just counting the boxes, like counting the distance from one side to the other. Miss Yama is going into depth because sometimes we won't have the boxes to count, right? Like we won't be able to count those boxes because they won't be on the screen for us. For today, if you're feeling comfy, you can just count from -5 to 2. We're basically saying, what's the distance from -5 to 2? We have to go 5 to get back to 0 and then 2 more. We have that 7 there, right? And then what's the difference from 0 to -3, right? We're going from 0 to -3. That's going to make it a distance of 3, right? So if you're thinking like, why can't I just count the boxes? You can count the boxes. That's not a problem. Ms. Yama is just teaching you what to do when the problems get a little bit more challenging. So y'all are doing a great job. Yes. Ms. Yama, can you see the results of the poll?
Yes, I can.
I'm gonna go ahead and end the poll.
Okay. Okay, thank you. So I think we're mostly at 3 and 4. And we have a few people still at 1 and 2. That's fine. Just let me know, like message me, like so I can see where I can clarify better. But we can try to get that in our next example. If we can do that, that'll be awesome. All right, let's jump into our next example. Let's see if I could go to the next slide. Oh, am I in the next slide? There are a lot of tabs going on. Okay, cool. I think this is it. Is it?
So why don't we take a moment? I think we're on slide 8. Why don't we take a moment? Why don't you all try to at least plot these points on your own, right? And try to go through the steps and see if you can solve it yourself on your screen. And then in about a minute, Miss Yama will come back and work through this problem with you, right? So since we're in a varying levels, let's go ahead and try it on our own first. And then you'll know exactly where you got stuck. And so you'll be able to pay attention to that part. See lots of really great triangles being drawn. That's a great place to start. You're plotting the points and drawing the triangle.
All right. Okay. I'm gonna start plotting, and then you guys can check whether you guys got the same points as me. So first point, -1 and 2. So -1 and move up 2. So it's right here. -1 and 2. And then we have -3 and 4. -3. And then we'll go up 4. Okay. Give me a second. Cool. Awesome. So those are the 2 points I got. Did everyone else also get these points? If not, that's okay. Let's just check that we have those points. Awesome. Okay, cool. So those are the 2 points we got. And right here is our right angle. So the side that's opposite of our right angle would be our C. So this is our C. And the other 2 sides would be our A and B. So for this example, we can just count. Let's just try counting. So for our A, we can count the square. We have 1, 2. So I know A right here is 2. Same for B. We went down 2, like 1, 2. And that's how we can get our A and B. And with that, we can try to plug it into a calculator. And we would be getting A, which is 2 square, plus B, which is also 2, plus 2 square equals C square. Equals C square. Okay, so 2 square, very quickly, can somebody shout it for me?
4.
Yeah, so we have 4 plus 4 equals C square, and 4 plus 4 is 8. So we'll get 8 equals C square. And to get rid of our square, we want to square root both ends. Square root, and we should arrive at C equals √8. Can someone plug that into the calculator? Oh, okay. Try plugging into the calculator. I'm getting different answers. No. So let's try to plug it directly into calculator and see what number we get with square root of 8. Thank you. So we should get 2.828. So we round it and we should get 2.83. Oh, I think the other class is coming in, and that's how we get the solution for this problem. All right. I'm gonna go to our next slide, and I'm gonna return this back to Ms. Mack.
Miss Emma, you can actually, oh, never mind. Hi team. If you didn't finish writing, that's a great question, Sebastian. If you go to page number 1, if you go to slide number 1, you click all the way back to slide number 1, you're going to actually see a YouTube video. And the YouTube video, which I will put into the chat as well here, the YouTube video is going to walk through these exact same problems in the exact same way, right? So the exact same problems here. Miss Yama already made a video for you this before we got started today. So if you go to slide 1, you'll be able to see that video, okay? That will lead you through all of the notes, For your assignment today, you have 8 problems, right? There are 8 problems from number 10, from slide 10 to slide 17. Okay, they're going to be exactly the same Pythagorean theorem, right? Exactly the same. So you can work through those on Desmos. Hold on one second. You can work through those on Desmos. And every time that you get to a slide, there's going to be a little like box. And on that box, you are going to fill in your answer. So let me show you real fast. Share my screen here. So right here in this box, anytime you see a little calculator keypad, right, you're going to type your answer in this box. So like this is slide 11. On slide 12, you're going to do the same thing, submit your answer here. On slide 13, submit your answer here. You should have room to write on the screen if you need to, like this, as well as you'll have a graph if you need a graph. But do make sure that you scroll down. There's going to be an answer box on every page. Okay, so slides 10 through 17. 17 is your last one. And then on slides 19 all the way to 25, these are all extra credit. So I know some of you love extra credit. If you love extra credit, these are for you. You can do as many, you can do 1, you can do 0, you can do all 6 or 7 if you want. Totally up to you. But everybody is going up to number 17. Okay. Remember, we have office hours today from we have office hours today from 10:30 to noon. So depending on where your Spanish, depending on when your Spanish class is, you can come if you have any questions on the note portion, or if you want to do the homework with us, we will do the homework. Miss, how do we turn it in? Great question, Melanie. You don't have to turn it in. Every time you do something on Desmos, it automatically updates me, right? It automatically updates me so I can see everything that you're doing. If you want to, you can take a screenshot and submit it on Canvas. If that makes you feel like more happy, you can, but you don't have to. But that would be how you can turn it in if you want. But I can see everything that you do. That's one of the advantages of Desmos. If you're writing on paper, I need you to email me your pictures. So if you're writing on paper, I need you to email me your paper. Yeah, if you do it on paper, you're gonna email me. Okay, if I did it on Desmos, how do I turn it in? Do I have to turn it in if I do it on Desmos? No. Yes, great, great. So if I do it on Desmos, I don't have to turn it in. If I do it on paper, how do I turn it in?
Email you.
Yes, email me, okay. All right, I love you. I am here for you. We'll be back here at 10:30 for you. Please let me know if you have any questions, and I will see you later. Everybody say thanks, Miss Yama. She did a great job for her first time. Emiliano says, thanks for another amazing lesson. Thank you, thank you. All right, y'all, you can sign on out. I will see you all later.